So the information that is given is the voltage drop across this 2 ohms resistance is 4 volts, and I need to find the current IA here. So what I can do is there are two type of source here, more than one sources. So I can apply principle of superposition. So first let's ignore the current source, that means may make the current source inactive. So since it's a current source, it will be open when it's inactive. So the new circuit will be with just the voltage source there. It will be like this. So 2 ohms, 2 ohms, and then here again basically this is 2 ohms, and then here 2 ohms. So 2 2 2 2, all of them, and this is 12 volts. Now this means that this is one parallel path, so 4 ohms here, and then another parallel path. So two parallel paths, 4 ohms, 4 ohms. So basically the equivalent resistance is 4 4 4 4 parallel 4 is 2, and then the current that is coming out of here is 12 over 2. So I, which is this one in this case, is 12 over 2, which is 6 amps. And since these parallel paths are of equal resistances, so it will be just divided by half. So the current through this one, basically, which we are interested in, is 3 ampere. So the voltage drop due to this one will be 6 volts, just for the voltage source. The voltage drop in this resistance will be 6 volts in this direction, but it is given that the voltage drop in this direction is actually 4 volts. So basically now we still haven't considered the current source because we are applying just the voltage source effect. So if we consider the current source, we know we need to have a 2 volt voltage source voltage drop in this case, so that the final result is 4 volts in this direction. So basically, due to the current source, a current of, since this is 2 ohms, to have 2 volts voltage drop, we need just 1 ampere current. So a current of 1 ampere needs to go the other way, this way. That's what it has to be. So this information we will use to find the current. So anyway, before doing that, let's erase this part quickly, and that we can now in this case we will consider only the current source. So the voltage source will be inactive. So this one, this one, this the current source, and voltage source, since we are making it inactive, it will be short circuit. So here this one, and then this one, this is I. So again 2 2 2, I am not writing the ohms thing, just ohm symbol, so just that way. Yeah, so this is IA. Now if I say this one, I want to redraw this one just for better understanding. This node I am designating as A, this one B, this one C, and this one as D. If I do that, so what I can see is basically, since B and C is short, it is actually basically the same node. So it is becoming something like this for me, just if I am allowed to draw like that. So this is the current source here, and this is node A here, and this one 2 ohms here, 2 ohms here. So B and C, the same node, and this 2 ohms is going from C to B, C to D, sorry, and B to D. So basically this, if this is D, since C and B are the same, this one is there, and the voltage drop we are interested in is BD, which is in one of these things, since these are parallel, so in one of these ones. So, and the voltage drop has to be, since we figured out before that the voltage drop has to be in the other direction, so it has to be D to B, and we need it to be 2 volts. That's what we need. So yeah, so basically we need a current source here. We need to figure out what the current is there. So we can see that there are four paths here. So this current goes this way, and then 2 ampere here, 2 ohms here, 2 ohms here, 2 ohms, 2 ohms resistance, and 2 ohms resistance. So this current, we need to have 1 ampere in this direction. So basically if we assume the current is going that way, so this current is negative, whatever current is coming out of here is split in half here, and then they are becoming the same current here, and then again split in half and then coming back. So basically if we need to have 1 ampere here, this current has to be, there will be 1 ampere here as well, 1 ampere here as well. So the total current has to be 2 amperes, and it has to be negative because the direction of IA is upwards, but we need to have it downwards according to that picture. So 2 ampere is the current, and it will go, since it will go downwards, it will have a negative direction. So in